In this problem we want to do an example of integration by parts with a definite integral. So we have the integral from 0 to 3 of x e to the negative x dx. And again we have to ask the same basic question. How do we know that we should use integration by parts with this particular problem? The answer is, first of all, we have a product. We could attempt to do u substitution, but using u equals negative x would give us du equals negative dx, and we wouldn't get rid of the x from this particular instance. So u substitution is not going to work. We have a product that cannot be further simplified, and so we look to integration by parts. And so once again we start with our formula. Integral u dv is equal to uv minus integral v du. And remember Lipit. I won't write them all out here, but we're trying to identify which function should be used as u. And since x, which is polynomial, comes before e to the negative x, which is exponential, we're going to let u be x and dv be e to the negative x. And the differential of u is dx, and the integral of dv is negative e to the negative x. And ordinarily we would do u substitution with e to the negative x, but I think it's clear that the result of that will just be negative e to the negative x. Now we're ready to put it together. And uv is negative x e to the negative x. And because this is a definite integral, I'm just going to wrap that in 0 to 3, which means we have to evaluate that term from 0 to 3. It doesn't mean that that is an antiderivative in and of itself, but we have to evaluate that product from 0 to 3, or evaluate it at 3 minus evaluate it at 0. And we're going to subtract from that the integral from 0 to 3 of v du, which turns out to be negative e to the negative x dx. Now that negative in front of the e to the negative x has got to come out, and that will change the sign to positive. So this would be the first step when we're doing a definite integral. We wrap the uv, or the negative x e to the negative x, in brackets and evaluate that at 3 minus evaluate it at 0. Now there are other ways to do this. I could finish the entire thing and then evaluate the whole thing at 3 minus the whole thing at 0, but this is also just as easy. So the first part of that, negative x e to the negative x evaluated at 3, gives us negative 3 e to the negative third. When we evaluate that at 0, the whole thing is going to become 0, because x times x is 0, and 0 times anything will give you 0. So that first part will just be negative 3 e to the negative third. Now we're going to antidifferentiate e to the negative x, which we've done already, and that's just negative e to the negative x. And we're going to evaluate that at 3 minus evaluate it at 0. Notice that I moved out the negative sign because it's a multiple, a constant multiple of the entire term, so that can be moved out. So when we start evaluating e to the negative x at 3, that's going to give us e to the negative third, and then minus e to the negative 0, which is going to be 1. And finally, when we simplify that out, we'll get negative 4 e to the negative third plus 1. And that does it for this problem. And this is an example of basic integration by parts with a definite integral. And that does it for this problem.